Okay, so this is the last lesson for the unit. I think it's 2.5. Hold on. All right, so this is going to be just a continuation of lesson 2-5, and we're going to talk just specifically about no solution, because you saw that on the homework about 3 or 4 times, and infinitely many solutions. For equations. So again, our world doesn't always work out perfectly where we find one number that will fit perfectly and give us a statement that's true. Sometimes we have no numbers that will work, and we can't solve that particular problem. Sometimes we have every single number that exists will work. Okay, so we have to be used to the fact that it's not always going to work out pretty. So today's date is 12/1. Okay, so what I'm going to do is to share with you different types of solutions, and we're going to start with the one that you guys are used to seeing. We're going to talk about it in words, we'll talk about it in symbols, and then we're given an example. So I'm going to write those 3 over here. So words, symbols, so that's usually algebraic, and then an example. So the one that we've done the most is if we have one solution. When we have one solution, in words, there's one answer. One and only one number that made that original equation true. When we solved an equation that involved this, it would be something like this. A variable equals and then a, and a equals a number. So algebraically, we have our variable as x, but a represents some sort of number. And that's what the vast majority of this entire chapter, when you've been solving your equations, that's what you were getting, one solution. So an example could be 2x equals 20. Divide both sides by 2, and you got x equals 10. Okay? So again, 98, 99% of all the questions from this chapter ended with one solution that worked. All right, so yesterday you had a couple of problems where there was no solution. Now I'm going to introduce a term and we'll define it in a minute. This one is called the null set. Null set. So in words, no solution. In symbols, you would get A equals B. A and B numbers. Use the number symbol. Oh, that's a terrible number symbol. Let's try that again. So you have one number is equal to a different number. A is not the same number as B. Okay, that's why I use different letters. If I wanted them to be the same, it would be the same letter. So you would have something like this. 3x plus 4 equals 3x. So when I would subtract 3x from both sides, I would get 4 equals 0. But 4 doesn't equal 0. So there is no answer that's going to work for this problem. And you saw that happen on, let's see, question 5, question 19, question 8. They had no solution because you had a number that was equal to a different number, and that's not possible. Okay? Now the one we haven't talked about that I'll share with you today is what's called an identity. An identity, the words that go with that, comes from our title, Infinitely Many Solutions. Now, I'm going to go back to null set for just a moment and add a little thing that happens. When you're solving this equation in the null set, what happened to your x? It got canceled out. So the x was completely, the variable was gone out of the problem. So that's something to note, is that the variable is eliminated. Okay? So now we're just down to a number and a number, okay? In the identity, the same thing happens. So I'm going to write that down here. The variable is also eliminated in this one. Okay, so what does this look like? Well, in symbols, I would get A equals A. Now, again, if I see the same letter, they mean exactly the same thing. So that basically says what's on the left is exactly what's on the right. So the number is equal to itself. So the number is equal to self. Okay, looks like TI, doesn't it? 2. So let me give you an example of what that would look like. 4x plus 2 equals 4x plus 2. Now, before I do any math, what can you tell me about that equation? What do you mean?
Like the same problem.
Yeah, if you notice, what you have on the left is identical to what you have on the right. I have a 4x on the left, I have a 4x on the right. I have a positive 2 on the left, I have a positive 2 on the right. Those two halves are exactly the same. Well, if I try solving it, I'm going to try to get the variables together. And again, that's where we have elimination takes place, and I get 2 equals 2. Okay?
So that's all you would have to write, like on the test?
Yeah, what if you recognized right here, this side and this side are identical. Now, identical means they could have the order changed. It could be 2 plus 4x, but it's the same 4x and the same positive 2. If you recognize here, this half is identical to this half, then you don't even have to do work. You can say identity, done, or infinitely many solutions. Those would be your 2 answers that are acceptable in this particular case. Okay? Some people also use the words all real numbers. Anything can go into that for that variable, and I'm going to get at the same thing. This one, if you recognize here that I've got the same exact variable on both sides, so when I do math to get them together, they're going to cancel out, but I'm not going to have the same numbers on both sides, then you can say, hey, I already know that this is going to be no solution, or it's going to be the null set.
What happens if someone accidentally subtracts 2 instead of negative 4x?
If you subtract 2, well, again, you're solving for x, so you have to keep going. So that's a good question. Give me a moment, and when I have more screen, we'll do that problem out all the way, okay? That's a great question. So let me put some words in here. Let's talk about null set for just a second. So null set is a way of saying, because when we have solutions, we put them in solution set notation, and that's like those little braces, looks like a forehead, a nose, and a chin. And what happens is that it looks like this. What's inside of the solution? What do you see between the 2 braces? Nothing. There's nothing there. It's empty. It's null and void. If you've ever heard that, null and void, it's done. There's nothing there. Okay? So this is also known as the empty set, because there was no number I could put in there that would say this is going to be true. So the null set is just another way of saying there's no solution because the set of answers is empty. There's nothing in there. Okay? So on the other hand, an identity, we can say is all values make the equation true. So something that you should pay attention to is anytime you're solving an equation and your variables are eliminated, you know you're going to have one of two answers. No solution, all, or identity, or infinitely many solutions, whatever you want to say for the last one. So those are the only two options. You're not going to get an actual physical number for those. Because we're solving for the variable. That's the whole point to equations. So if the variable is eliminated, we have nothing to solve for. So now we just are left to interpret what our answer is. Okay? All right, so let's go back and let's deal. Are everybody good with this one? Anyone still writing? We're good? Okay, let's go to the next screen. I want to go back to the question that Maddie? Good, Maddie. Came up with. So let me write that one down. It was 4x plus 2 equals 4x plus 2. So she said instead of dealing with the x's first, how about if you dealt with the constants, how would that change? So if I would subtract 2 from both sides, I would get 4x equals 4x. Now again, I'm trying to solve for x, but I have x's on both sides of the equation, so I would have to do inverse operations again with the x's. So I would subtract 4x from both sides. And when you subtract something from itself, you actually get a number, and that number is 0. So we're left with, when does 0 equal 0? Really? 0 doesn't equal itself?
Well, unless it's that answer.
Okay, what's right there? It says 0 equals 0. When is that true?
When you subtract the same number.
When does 0 equal 0? Always. Yeah. There's not a time when 0 can't equal itself. There's not a time when 2 can't equal 2 or 18 can't equal 18. Anytime what's on the left is identical to what's on the right, that's always going to be true. So since this is always true, you can think of identity. I like to think of it this way. All real numbers. So always and all start with the same letter, and so that helps me remember how to write the answer. There's actually one more way. You can also use this cursive R. That means all real numbers. So we've got options, lots of options when we have an identity. So identity, all real numbers, that little R symbol. You can even say that infinitely many solutions. Though I'm going to be honest with you, we tend to use this phrase when we're talking about ordered pairs, when there's an infinite number of ordered pairs that could make something true. So those are all options. Okay? So what we're going to do is just a couple of practice problems, and then that will do it, and then you guys will have some homework. And these types of answers will pop up on the homework tonight. So keep thinking. Always ask that question. When is this answer true? Never. No solution. Always all real numbers. Identity. Okay? All right, so let's just do a couple examples. Directions are going to ask us to solve. So let's see. Let's do 6 times the quantity, x minus 3, plus 10 equals 2 times the quantity, 3x minus 4. All right, so at this point, I have no idea what I have got myself into because I have a lot of math that has to be done before I can analyze what I have. So according to our equation card, what's the first thing I need to take care of? Yeah, I got to distribute to get rid of those parentheses. So here I'm distributing a positive 6. So 6 times x is 6x. 6 times a negative 3 is a negative 18. And then I have a plus 10. And then I have an equals. And now I have distribution on the other side. Positive 2 times a 3x is a 6x. Positive 2 times a negative 4 is a negative 8. Okay. Now on the left side, I have some like terms. It happens to be the constants. So I'm going to combine them together. And what's negative 18 plus 10? Negative 8. Oh, that's interesting. Okay. Yeah, this is going to, left side is identical to the right side. Now, if you're not seeing it, you go one other step and you say, okay, well, I'm going to get all my variables together, so I'm going to have to subtract 6x to get rid of that positive 6x, and oh, look at that goes away, oh, that goes away, and I'm left with negative 8 equals negative 8. Because this is always true, we can say identity. And that's all that I need to do. Now, Ethan, I think, saw it before we even did any calculations, once we had simplified each side. He could have stopped right at 6x minus 8 equals 6x minus 8 and written identity. But he didn't have the right to do that until he knew what he had. Okay, so you still have to do the distribution, you still have to combine like terms on a side, then analyze what you have on the left and the right. Okay? All right, let's do one more. 8 times the quantity 4 minus 2x equals 4 times the quantity 3 minus 5x, that plus 4, so the 4, or plus 4x. So the 4x is outside the parentheses. So again, we have the same issue we have always. We cannot do any analyzing, any kind of interpretation until we don't have parentheses, until we don't have terms that could get combined. So that's the first job, is to distribute. So we're going to distribute 8 times 4 is 32, and 8 times a negative 2x is a negative 16x. And then over on the other side, we're going to distribute the 4. So 4 times 3 is 12. 4 times a negative 5x is a negative 20x. And then I have the plus 4x. So I can't do anything on the left side. There's no like terms. So I have 32 minus 16x. On the right side, let's see. Oh, here are my like terms. I have a 12 and negative 20x plus 4x is negative 16x. Okay. Now, some of you might say, hey, wait a second, I noticed something a little strange here. They both say negative 16x. So if I try to balance this equation and get the x's together, what's going to happen to them? They're going to what? Yeah, they're going to cancel out. And then what am I going to be left with? 32 on one side, 12 on the other. Okay, so just to prove it out, we have these cancel here, and you're left, sure enough, with 32 equals to 12. So the question is, when does 32 equal 12? Never. So since this is never true, my interpretation is that it's no solution. You can say null set, you can say empty set, you can use that little 0 with a slash through it. That means there is no number I can put in for the variable and make it true, because the variables eliminate themselves from this equation, and I'm left with numbers only that don't make sense. So in both cases, your variables disappear, and you're left to only interpret the numbers left behind. When they're the same, identity. When they're different, no solution. Okay? That's it.